This is going to be a video demonstration of the Android version 1 project with Professor Patterson's Informatics 133 user interaction software, Android version 1 final application project. The one where you make sounds based on the position of the phone rather than typing out characters based on position. So, just quick video explanation. Quick talking about the code. We're going to be getting data from two sensors. One, we're going to be using, the first sensor we're going to be using is going to be the magnetic field sensor, and we're actually going to get true magnetic north to help orient our yaw, which is this axis, table flat, which is this axis, which is also called azimuth on the Android documentation website. And then there's going to be pitch, like that, and then roll, like this. And pitch and roll come from the accelerometer, and the yaw, or the azimuth, comes from the magnetic field sensor. And that, so previously there was this one method call to get this orientation data, but that was deprecated since Android 2.2 Froyo. So all the way in Android 5 is definitely a lot different. You have to use two data sensors. So one little caveat of using two different data sensors, especially the magnetic field link. When we were programming this app, where we were pointing was a little bit different. So our azimuth data, when we were holding it like this, was closer to around 300 degrees. So I'll have to be holding it like a little bit or something to get that in the range we had planned out. Yeah, so it's going to give us, so the sensors are giving out data in radians. We converted them to degrees and then shifted them all by adding 180. So now they all go from 0 to 360, just for a little cleaner visual UI output. And also for your if-else statements is just a little easier than having to worry with the kind of that, where it jumps from a negative 180 to positive 180 when you hit that very edge of the bound. And once again, this is azimuth, pitch, and roll. So let's go ahead and fire up the app and show you what our sounds make. And we wanted to honor the new Star Wars movie coming out and J.J. Abrams and his take on Star Wars, so we made a lightsaber app that makes different lightsaber sounds when you hold it in different positions. So let's just go ahead and give it a whirl and show you what we made. And as you can see really quickly right there, we have an event for the sound player. We have an event listener registered, so that once the application is finished parsing all the sound files, it lets the user know that it's like okay to use them, and that warning goes away. As you can see, this data is coming in real time. If it was coming in with, there's about, I think it's a 300,000 microsecond delay we chose. So basically it doesn't populate the UI too fast by getting too many callbacks. If it did, then the UI would crash and the application would crash, because there would be almost a sensor update being pushed to the UI every microsecond. So as you can see, it's going to populate as I populate and change values as I move about. Let's go ahead and show you it. So let me get, like I said earlier, we were in a different query environment when we made it. So true north, I guess, was facing this way. True north is always facing the same way. We were facing this way as we were making it. So there was the first sound, this position. Now if you go here, you're going to get that second one. Like that. Get that first one again. The third one. So the first one again. And we'll get that here. The fourth one. And that first one again. And the fifth one. Okay, there you go. And as you move it about, you're going to get a whole bunch of other ones. And there you have it. That's our app.